Welcome everyone, my name is Grund from the AISC GmbH in Germany, and together with my colleagues Julian, Tanke and Jürgen Gall from the University of Bonn, we developed ElliPose, the stereoscopic 3D human pose estimation by fitting ellipsoids. In general, we differentiate between 2D and 3D human pose estimation. In 2D pose estimation, we want to know for each key point of the body the pixel location, where in 3D human pose estimation we want to get 3D coordinates in space for each key point. Acquiring 2D pose training data is hereby the easier task, because it can just be clicked by hand. 3D pose data, in contrast, requires usually a complex setup, like a motion capture studio and multiple cameras. Previous work has already tried to shrink the cost of 3D pose data by reducing or even fully omitting 3D ground truth data. Pavlo and his colleagues, for example, strongly reduced the amount of data by using a backpropagation loss. MetaPose uses multiple cameras to triangulate poses and subsequently refine them using bundle adjustment, and Transfusion performs cross-view 2D pose refinement using a transformer encoder. This is why we present ElliPose. Given the 2D pose estimator is available, our algorithm only needs 2 cameras with unknown extrinsic parameters. If the camera distance is additionally provided, our algorithm is also able to acquire proper scale. Furthermore, our algorithm is, beside the 2D input pose, fully algebraic and therefore does not need any further training and can be adjusted to any key point definition. Most parts of our algorithm are based on epipolar geometry. Epipolar geometry describes the correspondences between 2D points on images from different angles, 3D world coordinates, and camera parameters. Those can be used to reconstruct camera matrices from 2D point correspondences, triangulate 3D points from known cameras, or calibrate a camera from known 2D and 3D point correspondences. Our algorithm consists of 3 stages: the triangulation, the multi-scale ellipsoid fitting, and the bone length correction. Hereby the first stage uses the mentioned epipolar geometry to simultaneously triangulate the poses and estimate the camera positions. Here we can see a result of the first stage. Clearly it can be seen that the triangulation is distorted in one direction. Therefore we use our second stage, the multi-scale ellipsoid fitting. To do so, we describe every bone not by its global position, but as the relative point of one of its respective key points to the other. Since the length of a bone should not change, we would expect this relative point to stay on a sphere over time. But if the pose is distorted, it stays on an ellipsoid instead. To estimate the ellipsoid, we use the least square problem solver by Turner et al. Here we mark the scaling factor yellow. Since every bone is distorted in the same way, we extend this parameter so that we get multiple t's, one for each individual type of bone. Using the fitted ellipsoid, we then undistort the pose, relocate the cameras, and retriangulate from the new camera positions. We repeat this stage until the fitted ellipsoid is similar to a sphere. In the final stage, we simultaneously minimize the bone length variance and the reprojection error. Our results show that ElliPose is capable on improving the results over a baseline approach consisting of only stage 1. This becomes especially clear for close camera pairs, here marked in red. Here we can see how the highly distorted pose at the top gets undistorted over multiple iterations of stage 2 at the bottom. The graphics at the bottom right shows the top perspective, also containing the camera positions. We also use the generated 3D poses to train the 3D human pose estimator by Pavlo et al. Hereby our generated pose performs better than any of his semi-supervision approaches. ElliPose is an easy method of data acquisition. It is independent of skeleton models, thus also usable for estimating poses of machines, animals, people with body deformations, etc. ElliPose 3D models are a good substitute for ground truth 3D poses and perform often better than recent semi-supervision methods. ElliPose also enables us to use lower camera distances for stereoscopic 3D pose estimation. Nonetheless, ElliPose does not work with moving cameras or unknown intrinsics. Thank you.